So yes, last lesson we were integrating composite functions where the baby function was a linear. So the way we did it was we identified, hey, it's a composite function, the baby is a linear. So we define the mother is u to the half, because square root of u is the same as u to the half. The baby must be 2x minus 3 subbed in, and the derivative of the baby is 2. So then we integrated the mother, which was a bit difficult, and then we multiplied it by the reciprocal of the derivative of the baby, plugged the u back in, and added c. And that's what we did for this one too. This one was a bit weird. This one was a little bit weird. So this one was a bit weird because it was like 7 over u is similar to 1 over u. And remember, the integral of 1 over u is ln u, ln x, where u is greater than 0. So we rewrote the function as we rewrote the mother function as 7 times 1 over u. And then you can take the constant out. If it's just a constant times a function, you can take the constant out here. And then you can integrate the function. So it's 7 times the integral of 1 over u du, which is 7 ln u. So the integral of the mother is here. And then we multiplied the integral of the mother by the reciprocal of the derivative of the baby. And then plugged back in u and then added c. But then remember, it's not possible for ln u, it's not possible for u to be 0 or a negative, because e to the power of anything will never go below 0 or never even reach 0 either. So hence we have to write u is greater than 0. But because u technically is the baby, 2x minus 3, we then in the final answer had to rewrite 2x minus 3 is greater than 0, which we can simplify even further by kind of solving for x, solving the inequality. So u is greater than 0, but then plug in u. You have to plug u back into the function and into here. Solve for x and then pop that on the side. So how about that? Now we started talking about where we've got other types of quirky functions in our course, in the SL course. Another type of quirky function which can be integrated in our course is one where it is the product. Yeah, product, remember, is the answer to multiplying. So product, meaning the answer to multiplying.
That's hilarious.
It's getting complicated now, isn't it? Oh gosh, that's badly, really, really calibrated. The one next time.
It's a C, right? It's a C?
So another type of quirky function can be integrated. Of course, the one is the product of a composite function and the derivative of the baby function. So these are harder to sort of see. So sometimes if you've got a bit of a wacky function and we ask you to integrate it, just have a look and see, is it
The same
two
thing.
things? Yeah, like, so here's a composite function. This part here is the composite function. The baby would be 2x4 minus 3x. Is the thing that's been multiplied by, does it happen to be the derivative of the baby? So what's the derivative of 2x4 minus 3x? It's that, yeah, you're right. Here's the composite function. It's this thing, x cubed minus 5x squared to the power of a half. What is the derivative of the baby? That, yeah, exactly. This is a bit of a wackier one. It's a product of two functions. The baby is 2x minus 3. What's the derivative of the baby? 2x, yep. So notice this is one where we're going to have to take out a half.
You just said it's 2x minus 3, that's x squared minus 3.
But the derivative is 2x. Okay.
You
Yeah.
said 2x minus 3.
Is the baby?
2x.
I was thinking to say 2x minus 3 and she didn't say that.
Oh, did I say
You
2x
said
minus 3?
2x
Sorry.
minus 3 becomes 2x.
I think it was a bit of a thing like when I said Olwen.
No, Kalina just said that you said 2x minus 3 equals 2x, but what you meant to say is x squared minus 3 equals 2x.
God, yeah, sorry, my brain, you guys are listening, but my brain said the derivative instead of the function. So I should have said, what is the derivative of x squared minus 3? I should have said, sorry, which is 2x.
Yes.
And so notice that this, it's not being multiplied by 2x, but it's being multiplied by a half times 2x. So it's one of the ones like here, where we're going to be able to take out a constant out the side. So that's a bit messed up. And this one, think of it as like 1 over this function. What's the derivative of this function? 6x subtract 4, which is what? So 1 over, so think of it as being 6x minus 4 times 1 over 3x squared minus 4x, and then it is a product of a composite function and the derivative of the baby. So what I was planning to do is to find what these two things are, just to point out what these things are. So this thing here that I'm pointing to is the composite function. Yeah, so what am I meaning by this? Just pointing out that that's a composite function with baby, or you can call it with you.
You gonna have a mother function?
Yeah. Huh? Yeah, there is a mother function. The mother would be u to the 5. The mother would be u to the 5, if you like. But I don't have much space, so that's enough. Just pointing out that here we've got a composite function, and what we've got going on over here is a derivative of the baby.
So the baby is 2x to the 4 minus 3x?
No.
Yes.
Yeah. Yep, that's the baby inside the bracket, and this here happens to be the derivative of the baby. So it's a particular kind of function, and where there's a special technique that we're about to learn. We haven't learned yet how to integrate these kind of functions.
How is that the derivative of the baby?
Ah, here's the baby.
Yeah.
What's the derivative of
Oh, yes.
8x3? Yep, minus 3, yeah. And so say if you see a wacky thing going on like this and you're asked to integrate it, then this is and you'll notice, just double check. Is that a composite function? Yes. Is it being multiplied by the derivative of the baby? Yes. And then it's one of these special kind of ones. And on the next page, I actually teach you how to do it. On the bottom of this page, I just prove that there's a technique. So this thing, which one of these, is that the composite function over here? Is this one?
No.
That's that?
Miss Millennium, all the arrows are green and then that one's blue.
No.
That's irritating.
Classic.
Really? I just did one. I just did one and I copied and pasted it all over the place. So I just did one and I copied it and changed it to green and I copied and pasted it all over. Maybe this was the first one I did. And I
You guys just call it blue.
So the first one, of course, is the composite function.
Why?
Yeah, composite function with baby, or you just say u if you want. Yeah, good. So you can say with baby, or if you don't have much space, you could say with u equals. That's composite. And then this thing is the derivative of the baby. This one's not the baby, it's the derivative of the baby. So
Okay, so the baby itself would just be x cubed plus 5x squared.
yeah,
And the fact that it's
correct.
square rooted is what makes it a composite function.
Exactly. Yeah, totally.
Sounds funny, Crystal.
So which one is the next one's interesting. Which part is the composite function?
And where I was in the north.
Come on, no. Oh.
That bit there is a composite, yeah. So it's a composite.
You mean, ain't that the baby inside the composite?
The baby is the
Yeah.
exponent.
Yeah, that's what we need.
Oh, yeah, okay.
So the
So what is the arrow?
The
Yeah.
arrow's not even
Ah.
pointed to the right
That
thing.
is a half multiplied by the derivative of the baby. Because remember when half time, you can do these ones, you can bang out a constant
Why
at the
is
side.
the arrow?
yeah, but why the arrow? Where's the arrow?
I think it's
It's
just
pointing to X.
So what is
No,
that?
but where's the baby arrow?
Yeah, where's the baby
What is
arrow?
going
I never
on?
put it, I never have a baby arrow. I just point to the composite function.
You have the derivative of the baby.
Yeah, the derivative of the baby is what we're about to define here.
That's
What-
the
so what's
So
the
X,
arrow?
X is what? That's the baby.
The derivative of the baby is 2x.
It's
Good
2x.
point. Yep, so the derivative of the baby in this case is 2x. So that thing is half of the derivative of the baby.
Oh, okay.
Oh,
But why did you have it?
Why do I even have it? Just to identify it's these kind of functions are how we integrate with this technique I haven't taught you yet.
That just doesn't make sense either.
It's confusing. So it's good that you're asking me
I'm
this
just gonna
question.
start writing complete funk.
Yeah, you get yeah. Comp funk, that kind of thing. So this one's an interesting one. It's a bit like that one on the previous page where we had 7 over u. So we did 7 times the integral of 1 over u. So that's what this one that I just did now. It's one of those confusing ones. that can be done still. So composite function is e to the x squared minus 3. So the mother function of that composite would be e to the u, and the baby is x squared minus 3, but it's being multiplied by x, and the derivative of the baby is 2x. But notice you could say it's half of the derivative of the baby.
But why would you use half and not be full?
It's going to be one like this, where we take out a constant and do like this. But you haven't learned the technique yet either.
Oh, that's why. So we're kind of doing it backwards?
Yeah.
Trying to prove that it works first?
It's a harder one. It's a trickier one to see. I probably should have put that one last. So out of these two, which one is the derivative of the baby? Top one. The top one, yeah. So the top one is the derivative.
Yeah.
Okay, I'm not going to skip this in. Der of the baby. So I don't have much space there and the board's messed up. So that one is the derivative of the baby u. What is the composite function?
I don't know. Because isn't the bottom one not the baby?
Yeah,
That's the baby is there.
That's the composite function. So the composite function has been multiplied by the derivative of the baby to make that. So the composite function.
Oh, they're all like that. Just that the rest of them you didn't work out the answer.
That's the composite function?
So what's the baby function?
The baby function would be
3x
squared. Yeah, that thing 1 over 3x squared minus 4x is the composite function, and the baby would have been the 3x squared minus 4x.
It's just so for that one you worked out that the product of the derivative and the composite would have brought up
Would have simplified. Yeah, exactly, yeah. For these ones, the product, we didn't expand them, we just left them next to each other and nice. Whereas this one, it was a fraction times the derivative of the baby, and they kind of combined them. So rather than write it as this green thing, and then 6x minus 4 next to it, they kind of combined it, which made it a little bit harder to see. So here, like, see how a lot of the work in these ones is even identifying that it's a composite function multiplied by the derivative of the baby. That takes quite a lot of brainwork to just even do that. So that's why I've made a big deal of this step.
So we should just be comfortable with being confused. Well, I should.
Yeah, you're getting into tricky stuff now. Yeah, exactly, because you haven't been taught how to integrate these even yet. You're just being taught how to identify that it's a particular kind of thing.
Oh, it looks like she understands.
I understand. This is fun.
It takes a bit of cognitive demand and stuff. So So a lot of the work was just identifying that these are special types of functions that we're about to learn the technique for how to integrate them. But what's nice about it is it's easier work. This is less work than what we were doing. To integrate them is less work than it was on the previous page.
Sure.
Yeah, because it turns out certain things kind of cancel out, and I'm going to prove to you why they cancel out, and then after that you can just believe that they cancel out.
You prove it. I don't believe you.
Exactly, yes. So basically, so guys, listen carefully. Guys, listen carefully. I'm about to tell you here. Guys, can I say? Oh, okay, fair enough. Okay, so I'm about to tell you, this is how you integrate these wacky functions. So I think most of the brain work is identifying that this is one of those kind of functions. The way you integrate them, basically you just integrate just the composite function, and the derivative of the baby function, this part here, kind of ends up being cancelled out in a certain sort of. So to some extent you ignore it. Basically you just integrate the composite function, and this thing kind of ends up being cancelled out. So to show you, not exactly cancelled out, but it's not important. So I'll try to prove to you, Bella, this is hard stuff, listen. So I'm going to prove to you, because you don't believe me. So how does that even work?
I think people say it after.
So you could say that if the composite function is written in the form of u, for example, u cubed or square root of u or 1 over u, then the baby function would be, oh yeah, so it's meant to be something straightforward. What letter do I tend to use for the baby function? U, yep. Initially I was thinking, what am I asking you? Luckily I'd written my answers up. There you go. So you could say that if the composite function is written in the form of u, for example, blah, 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 the baby function would be u, and the derivative of the baby function would be, well done, u dash.
Well done, Sarah. You're a
U dash.
star.
Another word for u dash is du dx. Remember du dx? Like there was the Leibniz versus Newton notation?
I can't
too many words maybe because of it.
Yeah, it's nice stuff, isn't it? So, why does u dash, why does it actually, what does du dx mean literally?
That's like Calvina. She just loves derivative.
Yeah, it means the derivative, Grace, it means the derivative of, what does du dx mean?
The function.
Yep, so listen, this is hard stuff. Du dx, don't mess around please. So the derivative of u means, the u dash means the derivative of u with respect to x. So the derivative of u with respect to x. So and I just made a point of that because I tend to use u dash just because it's way easier to write, isn't it?
In my exams,
With
I'm
the
going to be
UDX.
fine with that too, right?
Yeah. Oh yeah, totally. They understand what you mean by u dash, v dash, that kind of thing. Y dash, f dash x. They're fine with that stuff.
I wrote the derivative on y and u.
They get that. So so I just turned it into this because you're going to see that something's going to cancel out when we do this. So I'm rewriting u dash as du dx because you'll find something cancels out. So if the composite function was something like, for example, u cubed, like if that's the mother function, then the entire function in these types of questions could be written as u3, because notice it's a composite function multiplied by the derivative of the baby. Yep, so I think we should write that, shouldn't we? So here's the composite function. Yeah, these arrows. The composite function. Yeah, the composite function. The composite function, you know what? Yeah, like the mother function. The composite function, and that one on the side is the derivative of the baby. Yeah, the derivative of the baby. The baby u. And it's the product of them. So it's the product of these. Meaning those two things were multiplied together. So you can rewrite the whole thing as, if it was u cubed, for example, as the composite function multiplied by the derivative of the baby. So all I'm doing here is proving why, when you're integrating, you can ignore the derivative of the baby here for these kind of functions only. So because the function is one where it is a product of a composite function and the derivative of the baby function, I've just stated that kind of thing. Therefore, if you were to find the indefinite integral, like the one with plus c at the end, of this type of function, what you do is you find the integral twig of the composite function multiplied by the derivative of the baby with respect to x. And what cancels down here? Something cancels down in here.
Yeah.
dx is a goner. So you can cancel down dx, dx. So what does that leave you with?
The derivative, integrate the baby times.
Of u3 with respect to u.
Okay.
Yeah, so maybe I need to...
Wait,
Yeah, keep asking. Yeah, this is a bit wacky, this stuff.
One thing this video was I'm typing it wrong.
And you cancel out the dx, which is what we did here. So the dx means with respect to x.
How's an apple game?
With respect to x. Is this the finals or something?
No. Just a regular game.
And the du means with respect to you. Is it after school?
Yes. You want to come and see us?
Where is it? Where is it? Here?
Yes.
Oh, okay. There's so much netball going on.
You gonna come see us next Friday?
I might, but I've got math surgery.
So you want
That
it?
3 IBs were meant to be coming to see me for, and I think they've all cancelled on me. Yeah, that's true. Yeah. Yeah, and Talise isn't here, yeah. And because technically with math surgery, if no one turns up after 5 minutes, we're allowed to leave.
5 minutes.
that's not long.
After school?
Yeah.
You leave at 3:35?
Yeah, I tend to stick around for about half an hour at least.
Shouldn't.
But still at the moment, no one's turning up.
Because you do it on Friday after school usually, don't you? Or you change
I
to
do
Thursday?
every day 4. Yeah, because day 4, like I've got a 5-period day and I'm over there anyway, and so I may as well just hang out there and pack down for the day if no one turns up. Okay, so when you cancel out the dx, notice that now all you're asked to do is integrate the function with respect to u. which means just integrate the composite function u cubed with respect to u. What is the integral of u cubed?
3 and 2.
Yeah, 4 over 4.
Yep, these are the
Oh,
four
the other
way.
Yep. So u to the 4 over 4, and then plus c.
My eyes are tired.
So u4 or a quarter u4 plus c, and you would sub in the u. And you would sub in
You
the
don't have as
u.
much space as you do. Yeah.
And you would sub in the u.
C.
It's an international.
Yeah, at the moment we don't have a u. I'm just saying like an arbitrary example. So all I was doing there was pointing out that you just define the integral, the mother function, that like u to u cubed, and you integrate that and sub back in the u. It's as if the multiple of the baby of the derivative of the baby wasn't there, because see the dx's got cancelled out. Isn't that weird? So I just tried to prove to you why this is such a short method. So that's all I've done here. I've just tried to prove why this is an easier method. And it only works for these functions where you've got the product of a composite and multiplied by the derivative of its baby. Anyone writing still? We're going to do some examples of that. Of these quirky functions. So now you believe me. You totally believe me now, don't you?
What?
No, because it's all related back to here. Prove it. I don't believe you.
I don't believe you because of the
I didn't say that.
someone did. I said
Someone said it.
Then why did you say you don't believe her?
it. Hey, I just read it's in bright red, bold, a different font and everything.
Okay, let's move on. Kyoshi looks like she's going to get grumpy soon. Okay, if we don't move on. Okay, so now you believe me. Find the indefinite integral. So basically with the plus c bizo at the end of this thing. What's special about this function?
It's the derivative.
It's
They were in the last example.
yep.
It's the derivative.
It's the product of.
It's a composite function and the derivative of the baby function.
Bella, what did Grace say?
I can't drink water.
Oh, and don't do that. Oh, and don't drink Bella's water.
What did you say, Grace?
Oh,
Oh, I was studying the product of the composite function and the derivative of the baby function.
well done. Which one is the derivative of the baby?
I said that. The 8x3.
Minus
Oh, sorry.
3.
Yeah, okay, cool. So here's the derivative of the baby, this one here.
But how can you call that a product? We haven't multiplied yet.
Ah, yes, see, they're multiplied. See, when they're next to each other like this, it means they're multiplied.
Doesn't mean you have to multiply them.
No. It just means that we can use this special shortcut technique to integrate it.
So I would never have to actually multiply them.
No.
Oh, all right, thinking is that next step.
You could do that. That's the long way to do it would be to expand it, multiply it, work it all out, and then do it one by one. But this is a shortcut. But only works for these kind of things. So it's a product of a composite function. We're going to integrate these two. So here all we're doing is we're trying to identify that we've got a composite function multiplied by the derivative of the baby. So that's all we've done to start with. So now you believe me, find the indefinite integral. So see it, and it just says with respect to x, so the x is there. Next, write the composite function in u form. So this little green thing, you could call it u to the power of 5. Bella. Stop comforting Owen.
I think so is just the key denominator.
Where's Lauren? Oh, there you go.
She's hiding.
All right, you gotta see you have a lazy eye.
I can't, you're right. So here's u of 5. This is the baby. Maybe let's just make a note. This is the baby. It's not the derivative of the baby. It's just the baby.
Like how being is the baby of the class.
Of the year.
Yeah, because What is the derivative of 2x 4
Oh,
minus 6?
exchange, subtract minus.
Yeah, I probably should have pointed that out. Yeah. Okay, so what we've done is, so we've written the function, we've written the composite function in u form. So it was to the power of 5, so we just go u to the power of 5, whereby u is 2x to the power of 4 minus 3x. Now find the integral of the composite function in u form. So for this one, would you agree? This one's kind of a worked example already. Would you agree the integral of this one, u5, is u6 over 6?
Yep.
Yeah.
Plus c, but we can just
Yep,
worry about
I
the plus
agree.
c later. Lastly, sub back in u into the purple thing. And
That's my answer.
plus c. Notice that the difference between this and the previous page is we had to multiply that by 1 over the derivative of the baby. But we don't need to multiply by 1 over the derivative of the baby
When did we
anymore.
ever do that?
I'll show you where we did that.
Did we do it on only one question?
Yeah, that was dumb.
The ones on yesterday's lessons.
I think meant.
Because remember, see, we'd do the integral
Oh, you mean
times
page
1 over the
before last
derivative of the
page,
baby.
then.
Yeah, the page before last, sorry, yeah. Yeah, so with those ones, so when it's just a composite function with a linear subbed in, you find the integral of the mother, you multiply it by the reciprocal of the derivative of the baby, and sub everything back in. When it's the product of two things, so notice these aren't linear at all in these ones. So if you sort of, in your course, if you start to see somewhere there's non-linears inside the composite, try to have a look and see, hey, it's been multiplied by the derivative of the baby, and that means it's this kind of shortcut method. So it's less work. So see, all we did was we integrated the mother and then just subbed in u and added plus c. There was no multiplying by 1 over the derivative of the baby. It's actually less work. The most of the work is identifying that it's this kind of function. That's the hard thing to see. So it's a composite and so on, multiplied by the derivative of the baby. So that's lovely. So harder example, this is the one where, notice what is the derivative of the baby?
2x.
2x. Has it been multiplied by the derivative of the baby? Yeah, no, but it's been multiplied by half the derivative of the baby. So that's a bit more thinking. So that's always more annoying when that happens. That's my answers. I want to make sure I'm on track.
The IV did it.
Where is it?
The CFP with the IV did it.
Gracie's doing a runner. Okay. Oh, I've got to give more space here. Okay, so I think I filled this one in for you, actually. Yeah, I did. Nice. I kind of like had a little. She's a goddess. Okay, so I had a little thing in here. So find the indefinite integral. First of all, identify that it's a product of composite function and the derivative of the baby. So the composite function is this one, e to the x squared minus 3. So that's the composite function. But the derivative of the baby, notice it's half. Let's make a note. Notice it's half the derivative of the baby. Oops. This one. But notice it's half of the derivative of the baby.
But why then?
Just to make life hard. We can't make it nice and straight up. So x, it's half of the derivative of the baby. The baby is x squared minus 3. So it's half. So it's like e.g. it's half times u dash. Or half times du dx. So that's a bit messed up. Did I write anything else in there about that? Okay, so that means,
do it. I don't make sense, man.
and I'll point out like a way that you can rewrite it then. Like so therefore because of this business I've written somewhere, we can rewrite the original function. So I'm going to use blue because it's still the original function. We're going to say integrate half times 2x in brackets, half times 2x, that's the same thing as x, is 2x, and so that technically is the same thing as x, multiplied by e to the x squared minus 3, dx. So that's going to be multiplied, it's just not nicely calibrated. And remember with it, when there's a constant being times by the whole thing, you can pop the constant out here at the front of the integral, which is half times the integral, if I'm doing this right, half times the integral, writing, 2x e to the x squared minus 3. So notice now I have turned it into, I've found a way to turn it into the product of a composite. So by rewriting the original function like this, half times 2x is the same thing as x. And remember, it's half, when it's a constant times all of these things, I can pop it out the front of the integral for that to do that. And now it's properly written as the composite function times the derivative of its baby.
So do you not need the dx at the end?
Yeah, you do, sorry. I should do that. Lazy me. Yep, so now the dx there.
I just feel like that half doesn't need to be there at all.
Oh, it's true. Oh, it doesn't.
It does.
Like, even to put it right back to the beginning and restore it, like, it just doesn't need to be there.
Yeah, it just factors in at the end. So the whole thing's going to be over 2 at the end. And then plus c afterwards. So now we're kind of thinking of it's basically a half multiplied by this thing, the integral of this thing. So now let's integrate this thing.
It doesn't.
So next,
With itself.
yeah, it does. Yeah, you're right. So next, write the composite function in u form. The composite function is e to the u, whereby u, the baby, is x squared minus 3. And remember, you ignore this bit here. Now find the integral of the composite function in u form. For, as Calvina said, for e to the u is not that is the one that's on the bus and doesn't get scared. Because
Because it's not the form.
It's our joke that started off this.
Oh, there we go.
that one. So e to the u doesn't get scared. He says, "Are you not scared? I'll integrate you. I'll differentiate you." The other person says, "I'm not scared. I am e to the x."
And you all were just like, no, we don't get it.
Was I here? Where was I? All right, so that's why, like Calvina said, the integral is e to the u plus c, but for these ones, let's just pop the plus c at the end. So now find the integral of the composite function in u form. For that thing, the integral is e to the u. Last, multiply by the 1/2 part. Multiply in the 1/2 and sub u back in and throw a plus c on the end. Trying to do it in blue. Oh, because remember this weird technique, this weird method? You just integrate the composite as if that one's not there. And the proof was because of this thing. When you integrate these things, when you set this up,
Oh, it cancels out.
yeah, the product of, yeah, the dx part cancels out, yeah. So technically it means integrate u3 du, just with respect to u. So it's as if it's not there. Whoops, I should be down here. So that's what we've done. Now we factor in the 1/2. So see, that's why we've got now e to the u. I've sub-backed in the u, and I've multiplied by 1/2. So we could have also said, like you remember the other way we can write it, or we can write 1/2 e to the x.
But if we had
squared.
that, then we could just get rid of the over 2. If we didn't cancel the 2x out,
Yeah, exactly.
then we could just get rid of 2.
What two? What two?
Derivative of the integral of 2x would just be
And
what would the integral of 2x be? It'd be
2x squared over
over
2, which is x squared.
Yeah. So how does
And the great thing is about this technique is when you've got the composite multiplied by the integral of its derivative of its baby, you can integrate this as if that thing's just not there.
yeah?
So when you're integrating, it's as if the derivative of the baby is just not even there. Because of that proof where it got cancelled down. The dx's got cancelled down. It's confusing, hey? See. So that's a bit of a weird one. So it's an easier technique. It's an easier technique. The hard thing is to identify that you've got this thing going on. Hmm?
Is this the last page?
Yeah, it is for this lesson. Yep.
Oh, there's more coming.
Yeah, there's an L3, but we'll see. This might take a while to get through this, and then there might be only 10 minutes left.
So it's gonna get worse.
No, I don't think so. I think this is. I feel to some extent this is the worst.
Okay.
Sometimes it can get tricky when we want you to sub in numbers and solve
It says
as well.
father example.
But I think this is the most. But you guys are pretty good at subbing in numbers. Where?
Father example.
Oh yeah. Yeah, fair enough. All right, yeah, sure thing. Okay, guys, let's hurry up and finish so Kiesia doesn't miss a lot. Find the indefinite integral. The integral of the composite function multiplied by, what's the derivative of the baby?
Oh, that 3x squared plus 10x.
Plus, yeah, so double check. So double check, guys, don't do that, please. So double check that the derivative of the baby happens to be the other factor, the other things you're being multiplied by. Yay. So first of all, identify that it's a product of a composite function. So, that's it there. No. And the derivative of the baby.
So
So,
what happened to the square root?
the square root's part of the composite function. So the composite function is the entire thing.
No, but what's it?
The derivative is the derivative of the baby function.
Oh, I got you.
Finding
Yeah.
the baby function.
Yeah.
That's fine.
That is so true. So we've done that. Okay, so sometimes I'll show you just a thing that I like to do to test that thing out. I kind of go, okay, u is x cubed plus 5x squared, and I go u dash equals 3x squared plus 10x. Gosh, what happened there? 3x squared plus 10x.
This is one of those topics where every time I think I'm understanding, I realize I'm not.
Yes, it is. Yeah, I would say like it's probably going to take like quite a few lots of practices to just get the technique in your head, kind of thing. So I just did that. Like say we just did it in our head before. We just looked and said, "Hey, yes, it is." But if you want to, that's formally how you would do it. Next, write the composite function in U form. So how would I write the green thing in U form? Yep. What else? Yep. U to the power of a half. Whereby u equals yep. Now find the integral of the composite function in u form. For this one here, the integral will be
U1 to the 1.5 over 1.5, or 3 over 2.
yeah, u to the 3 over 2 divided by 3 over 2. And when you divide by 3 over 2, that's the same as timesing by 2 thirds, yeah. So timesing by 2 thirds, u 3 over 2. Lastly, sub the u back in and throw in a plus c at the end. So see, it's actually less work than, oh gosh. It's actually less work than when we had the composite with the linear subbed in. So sub the u back in. So I'm just going to write 2 thirds. I'm looking at the wrong page, that's why I'm getting confused. That's it. Where are we? 2 thirds. So it's 2 thirds. Sub in the u. The u was x cubed plus 5x squared. Let me know if I'm subbing the wrong thing.
Can I go to the bathroom?
Yeah. To the power of 2. And don't forget your little plus c on the end. So don't forget the plus c on the end. Yeah, you can totally leave it like that. You could have done 2 brackets.
Yeah.
X cubed plus 5x squared there to the 3 over 2 all over 3. That's also okay. But you couldn't kind of expand the 2 in because you exponents first. So that's why you couldn't expand in the 2. So sometimes just leaving it in a nice simple form is the best idea.
Wait, so I can't do it that way? I like it better that way.
Which way?
The way you just say it.
Oh yes, what I meant to was don't expand the 2 into the brackets, but you could do 2 brackets.
So I just, because I like that way. But you're saying you don't like that way.
No, this is fine.
Okay.
Over
3
plus C is fine as well. That's okay. Yeah, no, what I meant was don't by mistake think you need to do this stuff.
Yeah.
Because remember you're meant to do exponents before multiply anyway, so that technically is wrong according to Fed Maths. So just leaving it like either of these two is good. Come on. Okay. Oh gosh.
Have you just taken a long time to do that for
So it does tend to be less work overall. Harder example. Why is this one harder? Probably because it's 1 over. It's hard to see that it's a product of two things. It looks like a quotient, doesn't it? But it's a product of 1 over u multiplied by u dash. So what's an integral of 1 over u?
1? Yeah.
ln u. Yep, ln u. Find the indefinite integral, blah, blah. First identify it's a product of a composite function in
Is it uniform?
the thing, yeah. So I think it might be a good idea to rewrite it.
Yeah, so 1 over 3.
Yeah. Times by, like
1
that
over
thing,
3x subtract 2x times
multiplied
by
by.
6x over 4.
Yeah,
I mean,
6x
subtract 4.
minus 4. Something's wrong with the board. Increasingly worse with time. Okay, so see how we could rewrite it a bit more like that? Yes, that might make more sense. So then you can see, it might help you to, this is why it's harder, because it's hard to see that that's a product. But technically it's a product of this one multiplied by the derivative of the baby. And here's the composite. So we've got the derivative of the baby and we've got the composite.
Wait, wasn't we just? Oh, I got it now.
Yeah.
Never mind.
We've just rewritten the problem. So then it's easier for you to see that it's a product of a composite function and the derivative of the baby.
Doing that on purpose.
That's lightning going through it. So we've done that. Next, write the composite function in U form. So this composite function, the thing I've underlined in green, how could you write it in U form? Close? 1 over U, yeah. Let's do 1 over U to start with. I do that in blue, don't I? So 1 over U. Whereby U is?
Yeah, sorry.
3x squared minus 4x. Now find the integral of the composite function 1 over u. So for this one, so for, but what I mean by that arrow, for this, the integral is, what's the integral of 1 over u again? You guys said it before. ln u, yeah. What do we need to say on the side? Yeah. So ln u, oh sorry, u, yeah, u is greater than 0. Oh gosh. U is greater than 0. ln u. U is greater than 0. Life's good. Yep, nice. Yeah, we're done. Okay, cool. So once you realize what was going on, it's actually not a very hard one. It was just identifying that it was a product is what made it hard. Sub in the u and throw the plus c on the end. So.
And then you have to do 3x squared times 4x greater than 0, then solve for x.
Yeah, yeah, you can. But you know what? Like, because this is not a nice linear one to solve, they're actually fine for you to just leave it at 3x squared minus 4x is greater than 0.
Okay.
So when it's a bit more complicated one, like it's not a nice linear one to solve, they're actually okay with you leaving it. They're pretty consistent. Right? 3x squared minus 4x. Is this the end? Don't forget the plus c. And because it is a bit of a complicated u, but it's not a nice linear equation to solve, you'll find that they're okay if you just write this on the side. Well, the textbook they were anyway, when I looked at the samples.
is greater than 0.
Okay, bye.
That's the end of that. Oh wow.
Grace, I have a tissue, please.
Sure.
One day I'll buy my ear, Grace. Just one day.
Anyone still writing that? You can, that's fine. I'll just stop the video.